Okay, now we're at 7.3b, and we're going to talk about graphing using intercepts. Intercept means to obstruct from continuing to a destination. You're stopping it. When you try to pass a note to another classmate and the teacher takes it from you, that teacher intercepted the note. Even in spy movies, if they intercept the secret code, then that means someone stopped it from getting to its destination. Well, when a line on a coordinate plane crosses the x or the y axis, it's intercepted by that axis. So take a look at this graph right here. This line crosses the y-axis at 1. See it? Right here. That's where it's crossing the y-axis. That's the y-intercept. It's at 1. It crosses the x-axis. Here's the x-axis. It's crossing the x-axis at approximately negative 2/3. Do you see that? It's not quite on the negative 1. It's like 2/3 away from the 0. So that would be a negative 2/3. The x-intercept is the point on the x-axis where the line crosses, and the y-intercept is the point on the y-axis where the line crosses. We can draw a line by solving the equation for y to equal 0 to find x, and solving the equation for x to equal 0 to find y. And we can graph a linear equation using the intercepts. So if this is our equation, 4x plus 3y equals 12, to find the x-intercept, we let y equal 0. Now we just plug the 0 in for y, and we try to solve it. 4x plus 3 times 0 equals 12. Well, 3 times 0 is 0, so now we've got 4x plus 0, which is really 4x equals 12, isn't it? See? Now we divide each side by 4 to isolate the x, and that makes our friend the invisible 1 the identity property right there, so we just get an x, and 12 divided by 4 is 3. So now we've got our value of x is a 3. And remember, we set the y to 0. So now we can plot this x-intercept of 3, 0. And here's the x-axis, and we plot it at 3, 0. So now we've got our green dot. So now to find the y-intercept, we let x equal the 0. Now it's x's turn to be 0 to find y. 4 times 0 is 0, so we get 0 plus 3y equals 12, so 3y equals 12. See? Now we divide each side by that coefficient 3 to isolate the y. And again, identity property. This 3 over 3 is a 1 because the numerator and denominator are the same, so we have y equals 4. Now we can plot 0, 4 for that y-intercept. And that would be right here. It's 4 on the y and 0 on the x. And now all we have to do, because we found both intercepts, is draw the line. We connect them. So we just set each variable as 0 to solve for the other variable. See? Now, lines are easier to draw when the x values differ by at least 2 units. Otherwise, the points may be so close together that it won't be that accurate. It's going to be hard to draw. So if we use the coordinates of 1, 4, and 2, 5, then our 2 points are going to be right here. See? 1, 4, and 2, 5. And to draw a line with these 2 close little dots is really hard. It makes it difficult. And we don't know how accurate it's going to be. But if we use 1 for x and 4 for y, and then a 9 for x and an 11 for y, it's going to be more accurate because they're farther apart, see? We'll use this point and then draw our line. So you want the x values to differ at least by a couple of units to make a very accurate line. Or use 3 coordinates, right? 3 would really make it accurate. Okay, so now our next video is going to be 7.3c. We're going to graph horizontal and vertical lines. And if you want a link to the graphing of equations, or equations with 2 variables and solutions, or plotting points, or linear equations, those links are going to be in this description. And there's also going to be a link to my Grade 8 Math linear equation playlist. That might be very helpful too, okay? That playlist is going to have stuff that we haven't even talked about in this one yet, okay? All right, so I'll see you next video. I hope this was helpful. I hope you're having a good day. Keep trying. I'll see you. Bye.